Hello all, welcome to Code Hub. Today let us solve the LeetCode's daily challenge, and the problem is count good nodes in binary tree. Given a binary tree root, a node x in the tree is named good if in the path from root to x there are no nodes with a value greater than x. So we have if a node is good only if there are no nodes with the value greater than that particular node from root to that particular node. This is what the question is. Let us see a quick example so that it will be more clear. This 3 is already a good node because from the root to this node, this is the only node which is having a value 3. And if we consider this particular node, this is a node with the value 4, and the path from the root to this node there is no particular value which is having greater than this 4. So this 4 is considered to be good. And if we consider this 5, from this root to this node 5 there is no particular value which is greater than the value 5. So this node is also good. And for this one there is the path from root to this one is having a value which is 3, which is greater than this value 1. So this is not a good node. And for this particular node, if we consider the consider the path from root to this node, there is a maximum greater values 3 and 4 which is greater than this value 1. So this is not good. So how can we know a particular node is good or not? We can do some tree traversal, and if while doing this tree traversal, if we can say, if we can give a value to particular function, and if we check that particular node is having a value greater than the greater than the past value, then we can say that node to be a good. I will say it more clearly. If we consider the initially for the root node there will be a minimum value, we can pass a minimum dummy value, which is int min, because the node's value will be containing negative as well. So we can try to pass a value which is very lesser, which is int min. If we have a value which is greater than that dummy value, then we should know that this particular node is a good node. And while going to this left, what we will be doing is we will pass the maximum of the particular dummy node or this root of val. That is, the root of val 3 is maximum, or the int min, which is initially a dummy value, that is a maximum. So what will be the maximum? 3 comma int min, the maximum will be 3. So I will pass for the next recursive function, I will pass the value 3 as the dummy greater value to this particular recursive call. And in that recursive call, I will be checking whether the particular node's value is greater than or equal to this max variable. It is not so, and this one is not a good node. So I will again go for its left recursive call. While going for its left recursive call, I will be passing the maximum of 1 comma 3, which is 3. So I know that particular node, this 3 is greater than or equal to this the max value. So this is considered to be a good node. Next, I will also go for its right as well. While there is null, then I will return back, where then now I will be going to its right. Now while I'm going to its right, I will also check whether this particular node is greater than the max value, which is passed as 3. So it is greater. So this is particular node is a good node, and I will go to its left recursive call. By going to its left recursive call, I will pass maximum of the max node or the particular root val, which is 4. The maximum of 4 comma 3 is 4. So I will pass 4 to this one node, and I will check whether this nodes val is greater than or equal to this maximum value. It is not so, so this one should not be counted as a good node. Next, I will go to its right recursive call, and the same thing I'm checking whether this nodes val 5 is greater than or equal to this maximum value, and it is greater, so I will count this 5 as the good node. So ultimately, finally, we are going to have a good. Ultimately, we are having a number of nodes, total number of good nodes counted while doing this tree traversal. So what we are actually doing is, first we can have a count variable with reference. We will pass this count variable with reference. Finally, we are going to return this good node only. Good nodes. Let us name it as good. Let us name it as good. And we are going to do a tree traversal. In that tree traversal, what we are doing is, I will name that it as find good nodes. I will pass this root as well as good variable also, and this is going to be a private function, and this is a void data type I am declaring, and find good nodes, and the parameters pass the tree node star root and as well as the good variable which is passed by reference. And if my root is null, if my root is null, then we can just return. Else what I can do is, first we can we also want to pass a dummy max variable. The max variable is nothing but int dummy max. Instead of saying it as max, I will say it as current max, which is initially int min for the particular initial function. So this cur max is going to have my max variable, my maximum node I am seen so far in my particular path. If I have seen this current max, so this current max is going to have the keep track of the maximum value that is seen in the whole path from root to that particular node. So this current max is also passed, and if my root of val is going to be greater than or equal to my cur max, then what I can say is I can just increment my good variable, and then I want to go to my left recursive call as well as right recursive call. If root left recursive call root of left good as well as, now I want to find a maximum value, because I want to take the whether I want to pass the current max in the particular path to the next recursive call. So what I can do is I can pass it as max of cur max comma the root of val. Similarly, the same thing applies here for the right traversal. Instead of doing this thing, I can store it in one function temp max to be max of current max comma root val, and I can just pass this temp max to my next recursive call. And this is our complete code. Let us try to run our code now. We got correct answer, we got it accepted. Yeah, it got accepted for the example test cases as well. So what actually it is doing here is, we are just doing a tree traversal. It is nothing but root left right, that by in that process I am actually doing it. So it is just a pre-order traversal I'm doing here. First I'm having a current max initially int min. I'm passing the root good variable and current max to the recursive call. And if my root is null, I'm just returning. If my root is not null, I'm checking whether my current val is greater than the current max. If it is so, then this particular node is a good node. Then I'm just having a temporary variable which is going to store my current maximum of that current max or my root of val. So, and I'm just going to my left and right subtrees. Now let us try to submit our code. The time complexity here will be order of n, and the space complexity will be order of n. Since we are using recursion, that it may grow up to order of n. And that is it for today's problem. If you have any suggestions, let me know in the comments. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.